Okay, so working off of what we've been working with um, on yesterday's assignment, rate of change in slope. The slope, again, if you remember, we had talked about the slope being the rise over the run. Or another way of saying that, the change in y over the change in x. So most books, you will see the slope formula written as y2 minus y1 over x2 minus x1. Now, I kind of want to get you guys away from this y2, y1, x2, x1 deal. Because in the end, all we're doing is subtracting the y's over subtracting the x's. So when I'm looking at these 2 points right here, I have my x, I have my y, I have my x, I have my y. All I want you to do is just subtract the y values. So I'm going to subtract -2 minus -2 over -2 minus 7. Well, this is going to be 0 over -9, which is going to be 0. And remember that if you have a slope that has a 0 slope, or a line that has a 0 slope to it, then that is a horizontal line. All right. So 2, 5, 8, 1. So I'm going to again subtract my y values over subtracting my x values. Now again, what I want you, the x2, y2 is kind of mostly for you to keep the order important. So if you start here, start there for your x. So if I start here with my y, start here with your x. So here we have 4 over -6, which is going to give me a slope of -2 over 3. All right, so I want to move down here for a second. Um, Fractions. Well, it's not that bad because I'm subtracting my y values over subtracting my x values. Well, fortunately, they already have common denominators. So I have 5 over 5, which is 1, over 2 over 4, which reduces to 1/2. Now remember, when we're dividing by a fraction, we're really multiplying by the reciprocal. So therefore, this cancels with this, and my slope is 2. Now, yesterday we talked about kind of rise over run, all right? Slope being rise over run. Now, what I was telling the classes yesterday is when you're finding the rise over the run, sometimes it gets to be confusing when we're talking about up is positive, down is negative, right is positive, left is negative. Just do the rise over the run. So in this case, to get from this point to this point, my rise is 1, 2, 3, 4. My rise is 4, and my run is 2. So my slope is 2. Before you walk away from that, you ask yourself, is the line going up or down? In this case, it's going up, so my slope is positive. Where when I look at this one, here I have a rise of 1, 2, 3, 4, 5, 6, and I have a run of 1, 2. So I have a slope of 3, and because the line's going down, my slope is negative. When we're looking from a table, the slope is the same from this point to this point, this point to this point. Pick any 2 points and find your slope. So if I wanted to go ahead and use this point and this point, well, 3 minus 1 over -1 minus 0, which is 2 over -1, which gives me a slope of -2. All right. We're going to move a little bit further on down here and go to this. Now, find the slope of the line described by this equation right here. You have to take this equation, and we're going to start working with this more often, but I wanted to introduce it to you today, and put this equation into slope-intercept form, which means that I have to take 4x minus 2y equals 16, and I have to solve it for y. So the first thing I'm going to do is subtract the 4x. Now, keep in mind that again, I've canceled this out. I have the negative 2y. In slope-intercept form, it is some number times x plus the y-intercept. So I'm going to do negative 4x plus 16. Now I'm going to go ahead and divide everything by negative 2. If you divide this by negative 2, you divide this by negative 2, and you divide this by negative 2. So we have y equals 2x minus 8. Now you can identify what the slope is. This number in front of the x is my slope. So my slope is 2. We come over here and look. We're going to subtract the 2x. This gives me 3y equals negative 2x plus 12. Divide the 3. And so we have y equals negative 2 over 3x plus 4. And that's it for slope formula.